Algebra 1, Tuesday, December 7th, first period.
Years old, and then the one 7 days old. That's the funny
Can you leave that there?
It's Sam. It's Sam. Sam with you. Sam, you don't smell it.
Got it.
Oh, I saw now. It smells like crusty French fries.
Nice.
That's you, Sam.
Her.
I love Austin.
Wait, what did you say? Austin, what'd you say?
You said,
Oh, you're the one who's funny. Dude, smell your sweatshirt. It smells.
No, I'm not
Oh, your sweatshirt. Dude, this guy's on max bomb tower. I'm not gonna put it there. If he is on max cannon too, right there.
morning.
Push
How are
forward.
you?
Oh, it's right, bro. No offense, but your sweatshirt needs to go in the lunch. You know what? Uh-huh.
Yo, crap.
Alex, I need help. Where do I attack?
Wow. No.
Hey AJ, how's it going? Good, good.
Yeah, I know.
Good.
Yeah.
Good morning, Taylor. How are you?
They're gonna annihilate it. They're level 10.
Doesn't it smell like? You smell it? It smells like warm in here. Yeah, it's moist.
Now I'm going more.
Why? No, it's the one oh my god. I
With that? Is lighting it? Get the air.
One air. I that's no value at all. Or 2 air defense.
Dude, see?
Yeah, it's just like 1 air defense and annihilate that one. And I don't even have nice brain, but me.
Alex. Good morning. Hi, Karina. Good morning.
Yeah.
Good morning, Sandy.
Wait, I haven't even finished sexual class.
I can't play that.
Okay, so I can't answer what the hell is
It's more than like 100 countries. It's the biggest day.
Good morning, everybody. Happy Tuesday. Welcome to Algebra 1. We'll take the attendance.
Hey, just so you know I'm in the process of getting my teaching credential. I actually we do what's called observations. There's actually 6 of them a semester. So I've been asked to record one, which I'm doing today in this class. I've set it up so that you guys aren't on screen, which is what I have to do. If there is, I have to go back and edit it. So we should be pretty good with this, okay? So just so you know, that's going on. It's not a big deal. Just ignore it, but I wanted to call it out since it's out there already, okay? So let me take attendance, and then we'll jump into the lesson for today and talk about the test, the quiz and all that kind of good stuff, okay? So I'll give you a name, just give me a here. Thank you. Okay. Gracie? Ion? Darren? Kinsley? Ramsha? Is Ramsha here? Gavin? Hadley? Thanks, Hadley. Izzy?
Not here yet.
Sam?
Here.
Thanks, Sam. Sammy? Saw Sammy. Alex, I saw. Ellie? Good morning. Karina? Ava? No. Oh. Hey, Ava. There you are, right there.
Ava's here. What's your opposite?
Oh my gosh. Good catch.
Present.
Okay, that's cool. Austin? Hey, Austin. Sophia? AJ? I think Paul's out today. Jack? Emma? Taylor, Braden, and Addie. I think we're good. It looks like we've got a total of 3 and missing. Ramsha, right now Izzy, and Paul. Yeah. Sorry, I had them both up at the same time, so. All right. Well, welcome to Algebra 1 today. Three days left in the week, 8 in the semester, so we've got 2 sections last to cover. One of them we're going to cover today. We started on absolute values just very briefly. You may remember in the last class, but we're going to jump into it in detail in section 3.7. The other thing is just to remind you that we had a test, or quiz I should say, last week, and the redos of those are during access period. So I don't know where you guys are on thinking about that, but you do need to get a pass from me, and I've got them today. You can do them either day you want, but today would be the day that you'll pick up the passes, because I won't see you until, well, actually I'll see you tomorrow too, so I guess tomorrow you can pick them up. That's fine too, because you're actually first period in the block period. So access would be, the time to do it. Yes?
If you get a better score on the first test, can you keep that score?
Yeah, so the way it works is you have the I call it the math mulligan, right? So whatever score is better is your score. So there's no downside to take it a second time if you feel you need to work on that. If not, don't worry about it. But that's the plan. Yeah, absolutely. Whichever is the better score will be recorded for the quiz. Okay? Why don't we take a moment and go grab our journals, because we'll be working out of those today in section 3.7. So why don't you grab those journals and we'll start our day. Yeah, I will show you at the end of the class.
I started to do that test assignment, the open note thing, because I was already
You mean this recent test?
the
Previous exam?
one that you said that you all wrote was one
I just haven't posted yet. You got Let me get those out tonight. And then
No, because
tomorrow.
I didn't do it.
Oh.
That day and that day.
I know. Okay, I'll tell you what. Let me give you that tomorrow. Okay? And we can do that tomorrow. Especially since it's a block period. Perfect. Okay, thank you. I completely forgot. Thanks, Scott.
Yeah. And Sam, did you see your
Yeah, so those are not to be pulled out. Those are actually from my geometry class, and those are kind of,
It's like a weapon.
it is kind of a weapon. It's actually a knife, a cutting knife for taking. So let's leave all that over there. That's why that chair is there. You need a pencil? Absolutely, go for it. Thanks for picking that up. Nicely done. I do, and it's actually right over there in the far corner. It's plugged in. Give it a go. Pencil sharpener's back in business. It's back there. I know it's down for a couple of weeks. It's back in action. Better than ever. All right. So I'm going to start by showing just a quick summary of what we're going to do, and then we're going to jump into a quick video on that as well. Okay? Shall we do it? I think we will. Let's just do it anyway. So section 3.7 is all about graphing absolute value equations. I put this at this point in the, we're already through chapter 5. I skipped this section. Some of the other algebra teachers did as well, because some of the concepts that you've learned in the last couple of sections will make this a lot easier. That was a big jump from where we were to this one in the series of 3. So hopefully you'll pick up on this. Absolute value is a little bit of a different equation, as you know. I mentioned yesterday that the graph might be completely new to you. My understanding is, at least in San Ramon Valley Unified, they don't teach that in before algebra. So remember, it's the V shape that we talked about, and it's all about measuring really one simple thing, which is the distance from 0. You may remember that's really what absolute value is all about. It can be a negative number, it can be a positive number, but it literally is the count or spacing from there. We did this already with the volunteers, and you may remember that we ended up coming up with we used these 4 values, and then we came up with a picture that looks something like this, right? So this is what's known as a parent function of absolute values. Kind of an interesting name, but really, when you just have the function and you're trying to graph absolute value of x, this is exactly what it looks like. It makes sense, right? At 0, it's on the origin, so there is no distance, but each of those who go one step away, it moves up into the left or right. And it is always positive. Why is it always positive? It's because it's a measurement of distance from the origin, so therefore it's going to be a positive number. Okay? And when you start talking about domain and range, that's something that we've called out before and just want to kind of remind you. So the domain is what? Can somebody tell me what they remember what the domain is? Gracie?
Input.
It is. And the range is? Output. Well done. So the input is really all along this x-axis, right?
Yeah.
And you can see that it can be any value because these extend forever. Excuse me. But the range, as you said, called as the output, take a look at that. It's always a positive number with the parent function. Okay, so given the parent function, this is exactly what it looks like. And I just want to reiterate that again, this is a really important thing to remember, is that parent function. So in your journals, I think this is actually covered in section 3.7 a little bit, but you may want to make a note of that too. The parent function is a big term to remember. Okay? Within this shape, there's a couple of other things. Obviously, it's a V shape, right? It's a linear function, right? It's like y equals x, but now it's absolute value. So therefore, it's a linear function, so it'll be a straight line. There's something that's called a vertex, right? It's a vertex. You want to grab your journal? Like that. The vertex is actually the point of inflection, which means where the direction changes, and it's right there, okay? And notice one last thing is it's very symmetric. You can see that each side is almost like having a mirror. If you put a mirror up on one side, you see it like, hey, that's it. Okay, so those are the function. When you look at a parent function, those are the things to think about. Now, where do we go from here? There'll be a video in just a minute, but I did want to just kind of set the table for this. Parent function, see it over there, it's a V. It actually can move around in the coordinate plane. It can move around, it can go left or right or up and down, but still is an absolute value function. It's just moving around, and there's actually levers that move it. It's actually manipulated by numbers to move it in different directions. It can also shrink or grow, and we'll talk a little bit about that. I think this video covers that, and we'll certainly jump into that. So remember, parent function is where everything starts at the origin. And you can talk relative to the parent function that things move in different directions or are stretched or reduced. Okay, so here is, let's make sure this is working.
Battery 80%. Connected to Steve's MacBook Air.
Okay, guys, so here is our friend talking about absolute value graphs. And you can see, even before I jump into it, that there's a parent function here, right? See that? There's been one that's been actually flipped upside down and slid over to the right and up. That's kind of the absolute furthest thing you can do to a absolute. It's the furthest thing you can really do to that function. So let's take a look and see his general ideas. We're going to actually then jump into a couple more reviews of some examples, and then we'll get you into the journal. All right?
You know, the notation. So y equals absolute value of x. See those vertical bars? That tells us the absolute value. And what does the absolute value do? It takes whatever this quantity is inside of those absolute value bars, and after you simplify it, you always turn it into a positive number. So it's always a positive value. So let's go ahead and plot the parent function, this basic function here, by picking some negative values and some positive values. Okay, so when I put -3 in the absolute value, that's really telling us, like, what's that distance from 0? Is it, how far is it from the, from 0? Well, if you were to go on the number line, you can see here's -3. It's actually 3 units from 0. Granted, it's 3 to the left, but that distance is always positive. So this is going to be 3. The absolute value of -2, again, we make that positive. -1, it becomes +1. 0, the absolute value of 0 is 0. Now, here sometimes students make a little bit of a mistake. Remember, the absolute value always makes it positive. It doesn't make it the opposite. It just makes it positive. So 1 is going to be 1, 2 is going to be 2, and 3 is going to be 3. All we have to do now is plot these coordinates from the origin. So we've got left 3, up 3, right? Left 2, up 2, left 1, up 1, 0, 0, 1, 1, 2, 2, 3, 3. And what you'll notice when you graph these absolute value graphs, it has that real sharp V shape, that real sharp corner to it. So that's our basic graph. But now let's say we want to do more challenging ones. Say, for example, ones that are in this form here, y equals a absolute value of x minus h plus k. So how does this work? Well, the h, okay, is what shifts the graph left and right. Okay, so this number that's grouped with the x, it's easy to remember. It shifts it in the x-axis direction, left and right. But this one has the opposite effect on the graph. So that means if it's x minus 2, it would actually go +2, so to the right. If it was x plus 2, it would actually go -2, so to the left 2. But this k value actually has the same effect on the graph, meaning if it's positive, you're going to shift it up, and if it's negative, you're going to shift it down. Okay. Then what the a value does is it stretches the graph or compresses the graph. Okay. And if it's negative, what it'll do is it'll reflect the graph over the x-axis. If a is greater than 1, it's a vertical stretch. If it's between 0 and 1, like a half, it's a vertical shrink. Let's take a look at some examples so you can see how this works. So say, for example, this one here, y equals -2, absolute value of x minus 1 plus 4. Okay, what I like to do is I like to do the translation or the shift first. So what does this -1 right here do to the graph? Okay, well, if you said right 1, you're right. And then plus 4, what does that do? Up 4. Remember, this one has the opposite effect. This one has the same effect as the sign. So -1, we're going to go right 1, up 4, and there's going to be our vertex. Our vertex is this point here where the graph bends, right? Now, the -2, we talked about how the negative is going to reflect it over the x-axis. That means this graph's going to be opening down like this. And because this a value is greater than 1, okay, the absolute value of that is greater than 1, it's going to be a vertical stretch. Okay, so what that means is this graph is going to actually be opening down, but it's going to be stretched, which means it's going to be narrower. It's going down faster. But an easy way to graph these absolute value graphs is to think of this a value like the slope. So -2, we can think of that as -2 over 1. So from this point, we're going to go down 2, right 1. But notice it's symmetric, meaning it's the same about both sides of that axis of symmetry, that vertex. So if we go down 2, right 1, we can also go down to left 1, and we can repeat that process. Down 2, right 1, and same thing over here. We can go down to left 1, and see we're getting this nice V.
But hopefully you got a general sense of this. This is going to be a multi-day kind of review. That we'll be going into this as well tomorrow. So there's a lot to it. But we started with a parent function, right? And I like what he did. He identified a shift. When you start writing a more complex equation, it actually identifies places where the new vertex will go, right? The change in x and the change in y. You move that, and then he looked at the last piece, which is that multiplier, and that can either shrink or grow depending upon what it is, and it can be facing down or up depending upon whether it's positive or negative. So we're going to do a bunch of these things. You'll get through it. I actually, tomorrow we'll have a team event to do some of this stuff as well. But for today, what we're going to do is we're going to look at a couple more slides. I don't know why this cut off, but it is actually posted on slides, so you can go back and look at this again. There was a lot to that, right? There's a lot of information. But we're going to kind of go through a piece by piece and get there. Okay? Again, this was on a slide, so you'll be able to see it later if you want to. Okay? And it's posted on Schoology. There it is. Okay, so let's just, before we get into the journal, I have a couple of examples I'm going to show, and I'm going to talk about a summary of it. So really what we're going to do is this today and tomorrow, right, is translate these graphs of absolute value functions. You start always with that parent function and work from there. And then we're talking about stretch, shrink, and reflect graphs and move them around with transformations. That's all we're going to do for today and tomorrow. Hopefully this is something that is easy to see. One of the ways to look at it is certainly the way that gentleman was presenting, and this is actually something that you'll be doing in your journals here, is actually just graphing. That's another way to always, right, I mean not graphing, but to use points, right? So if you identify an equation, you plug in points, you're going to get a value, you can graph it. So in this particular case, both of these equations, which are shown over there, take a look at the difference here. It's a little simpler than what he was showing. The absolute value of x plus 3, notice the 3 is outside of the x. You may remember that means it's going to be a change in the y direction as a consequence. But first let's take a look at what it really looks like, right? So we're going to make a table of values. This makes it pretty simple if you're struggling with what does this really mean. And you can see that using the numbers -2 to 2 give you a somewhat of a graph here. You plot them, which you can see up above in the blue triangle. The black one down below is the parent triangle. The blue one is actually the graph of the table values. Once you draw the v-value, you can see that it shifts up, right? So because of this value being, again, outside of the x, outside of the absolute value, this one's inside. It's outside of it, it actually just shifts up. So isolating on that particular data point, right? So notice that something that's outside of x, it actually is the up and down direction. So when you're trying to locate it, you could have also done this, or you could have just said, hey, I know that's actually going to shift the whole parent function up by 3 on the y-axis. So that's all that happened here, right? 1, 2, 3, you're on your way to the races. So you can graph it if you're struggling with understanding it. You may be asked to do it, but here's another way to look at that and realize that this is that shift, right? See that? That's the shift. Any questions about that particular function? Good to go? Okay. So let's try the other one here. Notice that this is also going to shift in some direction, but the change is actually within the absolute value function. You can see, you know what else is in the absolute value function is the value x. So you can say, well, this is going to do something to x. And the one nuance that's a little bit different is that it has to be a minus, so this is actually going to shift something in a direction of a positive 2. If this had said x plus 2, it would have shifted in a -2 direction. So following first using the table values, going to 0 to 4, and then plotting them, you can see over there again in the lower function, it starts with black as the parent function. Blue is actually the function itself after it's been translated, right? And what happens is you can see x minus 2, said differently, is shifting over by 2. Do you follow all that? Move that phone away, please. Thank you. Again, let me just summarize. These are two things that are isolated in this example so you can see the impact. The first one is, hey, if I've got a shift that's outside of the absolute value equation, it's going to be something relative to y. Addie, can you put that phone away as well? It shifts up 3. See that? Pretty straightforward, and it follows the same sign. But inside the absolute value, it's got an impact on x, and it's actually going to need to take the negative of that, right? So Since that's minus 2, it's a positive 2, and that's the shift. So hopefully these examples, they're in the book, will help you understand what that particular piece of graphing absolute value equations is. Here's a couple of other examples I found. I just put them up here. I thought they may be worth looking at before you jump into your journal. You can see on the left side, it's shifting by 2, and it's also outside of the absolute value equation, so therefore it's going to go up since it's a positive number. So Taylor, if that was minus 2, where would you shift it?
Down.
You would shift it down. Okay, so do you get the idea? It's outside of the absolute value equation, so it goes up and down. Does everybody have that? Give me a thumbs up if you understand that. Okay, so here's the other one, right? Shift inside here, and we're going to take the negative of that. So a positive 3 becomes a minus 3, right? You have a question? Oh, you just gave me a little power sign. Okay, like power sign. Strength, good. Okay, so since you made that comment, it's our power person here. What would happen if this said x minus 3 inside the absolute value? Which way would you see Sophia, the change?
It would go left.
It would go, well, this goes left now, right?
Yeah. Oh, so it would go.
It go where?
It would go
You almost had it?
right.
Yes, good. Okay, so it's just remembering this one nuance that can be confusing. Inside the equation, it's the opposite of that number, right? So if it's a positive 3, it goes shifting to a negative 3, right? Or the other way around. And in that one, it goes up and down based on the absolute, the true value of that number. This is what he was talking about. This is the most complex thing that you'll need to deal with, right? I mean, I think if you can grasp the idea of a process and you understand the nuances of this equation, you should be pretty good. So let's talk about the equation first, right? So it's going to be in this form where you have an absolute value that's subtracted by something, and notice that that's a minus. So if that's a minus, it's going to go to which side, up, down, or anybody have a thought on that? If I'm going to shift it by h, which way am I going to go? Left, right, up, or down? Yeah, right, that's left. Okay, and what does this do here, the k value? Up or down? If it's positive, it's great. Okay. So last but not least is this factor here, which we haven't talked about yet. But he briefly talked about things getting wider or skinnier. It really means it's going to accelerate things. And it's a great call to look at it as a slope. Okay, and that leads me to how do you do the process here? This, again, is the most complex thing you'll see. So what you need to do is to identify, hey, I can identify the vertex as a ordered pair. And I can identify the slope of the lines coming from the vertex. And they reflect off each other. And if you get that, you're done. The last thing to remember, though, is if it's a negative number, it's going to go down. The v is going to point down. If it's a positive number, it's going to point up. Question?
No.
It's all good. I see the hand coming up a little bit. Okay. So we talked about this already, the shift. This is all in your slides. Here's the last piece, which we're going to isolate this piece, which is that multiplier, that a they showed up there, how it either makes the parent function skinnier or wider, right? Notice they have two examples. They've got, it's an absolute value times number 2, so 2 times the absolute value. And the other one is a minus 1/2 times the absolute value. But these are also right out of the book, and this is the other factor to consider. This first one is a factor of 2. Remember, we talked about, first of all, identifying the vertex. In this particular case, A and B, or H and K, I should say, are not showing anything, so it's 0 as a default, right? That's the parent function. And all you're doing with the parent function is you're going to multiply it by 2. There's the parent function in black, right? As it's going to show over there as well. All you're doing is you're changing the slope. So you start here. You can see with a parent function, the slope is 1. Now it's going to be 2, so it's up 2 and over 1 on both sides. You draw your line and you're done. Confused? Or good? Okay. So on the other one here, they also show a table, but we'll just talk through it. Notice, first of all, they drew the parent function, which is a great way to at least think about things. And relative to this, there is no change in the vertex because there's no h and k value. They're both 0, right? So it's a parent function. And then because it's a negative number, it's going to go down, right? Remember that? If it's positive, it goes up. This one goes down. And because it's a slope of 1/2, it's actually over 2 down 1, over 2 down 1. You draw your lines on both sides. Any questions? Okay. We'll all assume we're good. We're all going to work in the journal. I'll be walking around as well. You've got somebody right next to you you can work with if you'd like to. You can share the work. We're going to do pages. We're going to do 3 pages today, right? Okay, they're right up there. Pages 90. I want you to do it in this order, too. Do 90 first. You got it, Alex. Then do 94. And then we'll go back and do 91, okay? Yeah. So look, this is what's great. There's actually examples of here that you can use. And you would actually have this on a quiz or a test and you can look to it. So you got the function of g of x equals a times absolute minus h. So do you see that here? That's where you want to start with, and then you can figure this out. So this first part is really all about finding, looking at these equations and then trying to find the corresponding h. Exactly. Yeah. So no, not at all. You just need to identify. And remember what the parent function is. So everything's relative to the parent function. Right? Well, I'll help you do A. How's that? Okay. So first of all, with A, do you know what is it? Is there a is the vertex phase?
So the plus here I'm gonna have yeah. No. Yes it is.
What do you guys think? I got a yes and a no. I got 3 to go. Is it gonna move? No, and no. Is it just gonna move, or is it gonna be at the origin? Are you going to draw this absolute value from the origin? You're not. That's correct. So what you need to identify is the new location of the vertex. And the location of the vertex is, remember this? We just talked about this. It's in order here HK. Remember that? Okay. So it's right here, right? So you can see in the essential question, it actually shows you where H and K are. So can you identify with the first one with that new where the new vertex location? Well, I think first of all, just remember about the direction. First of all, identify H and K. By yes, H minus and what's that value?
How do you explain it?
Is it 80? Sorry, I didn't quite follow the details. So again, let me write this. Oh, you're talking about, I'm sorry. The first thing you need to do is find before you look down. Let's identify the vertex. And can I borrow this for a second? I'm gonna write this down. Yeah. Hey guys. So that first section on page 90. Hey folks, up here just for a second. Hey guys, just up for this first page, right? So there's a total of 6 questions, right? 6 questions. I mean, you're jumping it pretty quickly, right? So let's just talk about the first one. If you guys are okay, I'm going to actually work through it with you and ask for some help, okay? So our goal is to do this, right? Do you remember this, where we actually shifted the parent function to the left because of that 3? Do you remember that? And it actually is minus the negative 3. And then we shifted that up because we had the positive 2 outside of the absolute value equation. So here's what you guys need to do, and these are all written this way. You've got a function, or y, equals a times x minus h plus k. And by the way, this equation is the equation to be able to take you to solve everything, right? So the first thing you have to identify is, you guys up here? The first thing you have to identify is that there's a new vertex somewhere, potentially. If there's a value for h and a value for k, sometimes there isn't. Like I could give you this, I could say, graph this equation, f of x equals 3 times the absolute value of x. Is somebody singing? Okay, it's wonderful, by the way. By the way, take a look at this. So, it's actually quite nice. It's a good way to start your day. So guys, take a look up here though really quick so you can get you guys back in the journals. Braden up here?
Yeah.
Got it. Hey guys, take a look at this. F of x equals 3 times the absolute value of x. Is there any values for h and k here? Karina? Nice and loud. There aren't. Okay. That would mean then that I would have the location of the vertex would be 0, 0. Do you see that? So I want to find where my vertex starts before I do anything else on this stuff. So in each of these equations, let's take a look at the first one. Sophia, thanks for letting me borrow this. It says g of x equals a negative absolute value of x minus 2. So, Kinsley, take a look at what I just wrote there, and you can see right there that g of x equals a negative absolute value of x minus 2. Is there a value for, that you can tell me, for h and k there that you can read? So remember, look at this. That's the equation we're applying. So what's the value of h? You're so close. But notice this.
Oh, 2?
It is 2. Yes, and this should say absolute value, my bad. So there, hey guys, there's the value of h. You can see 2. Good job. And how about, can you identify the value, Austin, of k? In that equation, g of x, what's that? So what would that be then?
It stays flat, 0.
Well done. Okay, you just solved this thing, right? This is the hardest part. Well, there's 2 hard parts. This is the harder one, though. We've now identified, hey, because of this equation, right? This equation, we would have started at the origin, right? In this particular equation, because it has a minus 2 inside, we've actually shifted it by 2 in the x direction, positive 2. Good job, Karina, and good job, Austin. So now we have a new vertex location. So the first thing you would do then is you would identify where that is. I'll do that right here. You would actually take this little pen and put it right there. That is your vertex location, right? Good so far? We're all on the same page? We moved 2 because, Karina, you called it out. It was a positive 2. I think that was you. It was Kinsley. Good job. Okay. And then, Austin, you said 0, right? So we're right here. Good job to both of you guys. Now, what's the slope of this particular, what do you notice about the slope of this particular function? Does anybody call out something that they can know? Is there a slope identifiable in that equation? You think it's 1? Don't forget this though, right? Okay, how many people see that it's a negative 1? Can you guys see that? Because we need to make sure, Alan, you need to get that. You get that? If not, we'll explain it in more detail. Alex, I know you just came back, but we're talking about the slope of this. This actually is identifier slope, and if it says minus absolute value of this, do you know what the slope would be, Alex? Negative 1. Perfect. So do you remember when it's a negative number, what happens to the direction of the absolute value function? It goes down, right? And it's a slope of 1, right? Got me on that? So we identified this as 2, 0. Now it's just down by 1, 1, 1 each way like that. And we've just graphed our first of 6. So you don't actually have to graph all this, but you need to get the concept to be able to identify. You need to say, the best way to do this on this page here, page 90, is identify this, and then maybe even put in your slope, right? And this particular one would be minus 1. And it would be these 2 points here that I would have written down below. I would go 2, 0, and then a minus 1 and put it down that way. So let's take a look here. So now you've got 6 potential solutions. Darren, do you know which one looks the most like the one we drew? Darren? Okay, how about you, Gavin? It is D. Gavin, that's correct. Darren, do you see the why it's a D? So again, Darren, real quick, we have the vertex location. It's the only one that's on the x-axis that's going down, right? And that's the other piece that we know. The slope going down and those two coordinated together, you can identify which one it is. Does this make sense to everybody? It's a good start. Okay, so thanks for letting me take this. Why don't you guys go ahead and do the other 5 on page 90 and see if you can identify the y. Write for sure on write for sure below each equation what the new vertex location is, and then also identify what the slope is. Put those down on paper and then identify which one it is.
So this one would be a positive 2, so it'd be over here. And a negative 5, so it would be this one.
So write in, so we just did this, right? Write your ordered pair. Yeah, but before you do that, write your ordered pair of 2, 0. Do you understand the why it's 0 then?
Because there's no.
And what's the slope of m equals? That's your slope. Perfect. Okay, so from that you can identify if it's negative, it has to go down. So this is going to be a negative, so is that. That will be there's 3 points. It is. Did you guys get that? Yeah? Good. How's this going over here?
Oh, do you not know?
If you write that, you totally did. Okay, so you got 2. Good. Good.
Another 2. I'm guessing
You totally nailed it. Well done. So if you want to roll ahead a little bit, you can. There's 3 pages total. But go to page 94 next, and then come back to it. It's still 3 seconds. That's it. Perfect. Thank you. I'll be right back. Yeah, what's the slope? Why is it It was over here.
So shitty.
Why is it? Where is it?
Oh, it's gonna be an R.
I think
I remember that. Right.
Have you already done this other? Yeah.
So this one would be 2, so it would be
That's why write down the location of each.
Where did they go?
The negative.
So it would be A.
For this one we did, we multiplied by 1/2. This one we
And so this
multiplied
one
by
That is very true.
X is 2.
It's like literally like this.
The negative 2.
Now, the next thing you gotta do is identify, hey, I X 3 together, 2, 0,
Okay, I figured it out.
Where's the
Yeah.
Middle schoolers. Yeah, and they're like, oh, I'm like, girl, what do you mean? Oh my god, I've never done that. And you said making fun of someone. I get a picture, yeah.
Scratching your leg all over.
I'll get over here. We're cruising while you guys are rolling. I'll come back. You know, this part? Did you do the other one? Yeah, it looks like you're doing it.
I think she did like just early 8th grade. I remember like seeing her picture.
You guys did you identify the so make sure you write the, first of all, the new vertex location. I do that up here.
I was wondering for F, either A or C.
Or why would you say it's A or C?
It's plus 2, so it goes up, not down. And it has like a 2, so I think it's this one is 0.
Okay, so which one is not most likely to have number C? Well, what is the equation? Yeah? Okay, so what's the new vertex for F? You guys know what? Remember this equation?
What pages do we have to go besides that?
And the vertex is abstractly right here, but it's HK. So apply that to this one. Tell us what you
I don't remember drawing.
remember, look at the equation here.
I don't remember drawing.
That means that it's going to shift the x direction left to right, but it's an negative number. So you have to look at it and say, that's really, x plus 2 is also going to be So if you need to go x minus something, it's going to say, what would be the value of h then? Right, so like go to parentheses. Now look at the y value outside of this. It would be. So now you have a ordered pair. Can you do the same thing on this one? On C? Are you catching this happen?
Well, I think I will.
No, drop this and roll these That's absolutely great. You know, okay. Totally cool, you got it. You guys all six, right? I'll be over in a couple minutes, just want to make sure we get through this. Are you guys through the six or?
We're on 94.
You're on 94? Well done. So when we look at the sun, you sort of nailed it, right? It's not that hard, it's getting comfortable with it, right? Okay, what's this one? Okay, what's this one? You nailed it again. Are you just gonna add up that one? Yeah, look at one over there, A. Check this one, you get A. You got all six. Perfect. Let's take that. So, once you work on that, the next thing you want to think about is that slope. A value. What's the slope? What's the slope?
I need to talk to like myself. I don't I learned the 50 days I've been doing bullshit.
So, you've already graphed the idea. All you're doing is doing like those equations.
Like the song, I'd be like,
So now this is all the vertexes. You've got your six sections.
like that one line that's like and that's like all the 55 other countries. Brazil, all of Africa, all of it. Yes.
I'll let you do that on the back. Just start slow steps. How's it going over there? You okay over there, buddy? We're all
It sure looks like it. -4 becomes, well, you know what? These are all going to be positive numbers. Remember how we'll plug in. How many spaces away is That's the answer. Always going to be a positive number. 4 times a half is 2. Yeah, that's exactly right. Okay, so you're on your way.
Hey guys, we have a couple more minutes before class is over. Please make sure you get through all this. I am walking around, but when I'm away, I noticed some guys have drifted a little bit. Let's stay focused on the task at hand. There's only 4 questions on 94 and 1 on 91, so let's do that, yes.
See about that.
Hey guys, we still have like 6 minutes left. If you're done, so you need to plug this in. Yes, it's right. It's always got to be positive. Plug it away, get that done. Are we doing okay over here? Oh, that's awesome. You get to the last one. You get to the second one. I need you to do
I'm so mad. Owen touched my ball.
Right after
I thought the ball
She just asked. It's like let's not What's
Thanks so much. Back down. Yep.
the store? He does. Oh yeah, yeah. Oh, that's so serious.
Are we doing okay? All right. Did we get that done? You guys finished it? Want to come tomorrow? Guys, why don't you put your gear away? That's good. You put your gear away, guys, for today? Thank you.